Hello students, in the previous video we learned how to calculate the oxidation number of an element in the compound. Now there were some compounds in which the oxidation state of the element was in fraction. For example, this was our example and we were supposed to calculate the oxidation state of iron. So it is 3x plus 4 into minus 2 equal to 0 or x equal to plus 8 by 3. Here the oxidation state of iron is 8 by 3. Now, this is quite strange because the electrons are never shared or transferred in fractions. We cannot have 8 by 3 electrons. So, how to explain the fractional oxidation number or how to understand the concept of fractional oxidation number? Actually, this fractional oxidation number is the average oxidation number of the element in the compound. Now, what is the meaning of average oxidation number? Fe3O4 is made up of two compounds. Okay. Now here the oxidation state of iron is plus 2 and here the oxidation state of iron is plus 3. Here iron exists in both plus 2 and plus 3 oxidation number. Okay. Therefore, the oxidation number will calculate as average and the average oxidation number is plus 8 by 3. Okay. So fractional oxidation number whenever it comes, then we must say that the element exists in two different oxidation states in this compound. The same, one more example is Pb3O4. Now in Pb3O4 also the oxidation state of lead is plus 8 by 3. Again the same thing, lead exists in two oxidation state there, plus 2 and plus 4. Okay, so this is the concept of fractional oxidation number. Now we'll discuss few differences between valency and oxidation number. Valency is the combining capacity of an element. Okay, while oxidation number is the charge which an atom of the element appears to have when all other atoms are removed as ions. So oxidation number basically means charge. Valency is always a whole number. It cannot be positive or it cannot be negative. It is simply a number. While oxidation number, it is not necessary to have whole number. We can have fractional also. We can have positive or negative values also. Valency cannot be zero except noble gases, but oxidation number can be zero. Likewise, in general, we can say that valency is constant for an element. Okay, for a particular element, its valency will be constant. But oxidation number for an element differ from compound to compound. For example, nitrogen in one compound, its oxidation state is plus 1. It is possible that in other compound it is minus 2 or minus 3 like this. But the valency of nitrogen will remain same. Okay, so this is the difference between valency and oxidation number. Now let's begin with the main part of this chapter, that is balancing redox reaction. Now there are two methods for balancing the redox reaction. The first method is oxidation number method and the second method is ion electron method. So first we are going to discuss the balancing of a redox reaction by oxidation number method. Now first of all we'll discuss the rules and then we'll take the examples. The first rule is write the skeletal equation. So what we'll do, first we'll write the unbalanced redox equation, okay, that is skeletal equation. Now we'll calculate oxidation number of all the atoms in the reactant and product. Okay, so all the atoms which are involved in the equation will write their oxidation number on their top. Then we'll identify the element which undergoes a change in the oxidation number. Okay, now we'll locate the elements which undergo a change in oxidation number from left side to right side. Okay, usually two elements will be involved. One element will undergo increase and one element will undergo decrease. So we'll find out increase and decrease in oxidation number. So if oxidation number increases at some place, it is oxidation, and if it is decreases, it is reduction. Now we'll find out increase and decrease in oxidation number per atom. Okay, so per atom how much increase and decrease is there, then we'll multiply the increase and decrease with the number of atoms. Okay, this point will become clear when we'll take some example. So first of all, calculate the oxidation number, find out where it is increasing and where it is decreasing, and multiply that increase and decrease with number of atoms. Now the next rule is equate the total increase and total decrease in oxidation number by multiplying with suitable integers. Then we'll balance all the atoms other than hydrogen and oxygen. Now we'll finally balance oxygen by adding water molecules and hydrogen by adding H plus in the acidic medium and OH minus in the basic medium. So it will be mentioned in the question itself whether the equation is taking place in acidic medium or it is taking place in basic medium. So accordingly we'll add H plus and OH minus. Okay, so these are the rules regarding the balancing of a redox equation in by oxidation number method. Okay, but this method will become more clear when we'll take some examples. So we are taking few examples in acidic medium and few examples in basic medium. Now my first equation is copper plus NO3 minus gives NO2 plus Cu2 plus, and this equation is in acidic medium. Okay, now we'll try to solve. Now what is the first step? The first step says that calculate the oxidation number of all the atoms. So again I will write the equation and I will calculate the oxidation number of all the atoms. Here it is 0. Here I will calculate for nitrogen because oxygen I already know. What is the charge on oxygen? It is -2. So I will calculate the oxidation state of nitrogen here, that is x plus 3 into -2 equal to -1 or x equal to +5. So nitrogen is +5. Now here copper is +2. Now what is the oxidation state of nitrogen? X plus 2 into -2 equal to 0 or x equal to +4. So we have calculated the oxidation number of all the atoms. Okay, only two elements we consider, one that undergoes increase and one that undergoes decrease. Okay, now from 0 to +2 it is increasing, so it is oxidation, and from +5 to +4 it is decreasing, that it is reduction. Okay, so in the equation itself we'll mark that where the oxidation is taking place and where the reduction is taking place. Okay, now the second step. Now the second step says that what is the increase in oxidation number and what is the decrease in oxidation number. Okay, now we'll calculate 0 to +2, so increase is 2, and 5 to 4 the decrease is 1. Okay, so increase is 2 and decrease is 1. Okay, now the number of atoms we have to multiply, so here only we'll write multiply increase and decrease by number of atoms, but the number of atoms involved are 1 and 1 only, copper 1 and nitrogen 1. So increase is 2 into 1 and decrease is also 1 into 1. So total increase is 2 and total decrease is 1. Okay, sometimes it happens that here the number of atom is 1 but here it is 2, here it is 2, here it is 1, then accordingly we have to multiply by number of atoms. Okay, so number of atoms are 1 and 1, so total increase is 2 and total decrease is 1. Now the next step is equate total increase and total decrease. Now how we are going to equate, we'll see. So we have to equate the total increase and total decrease. Now increase is 2 and decrease is 1. So how we are going to equate? Now increase will become equal to decrease if you multiply the decrease by 2, because we can equate only by multiplying. So decrease we are going to multiply by 2. Now what is the decrease part in the equation? The decrease part in the equation is NO3. So I will multiply the NO3 here also by 2 and NO2 here also by 2. So whatever part is decreasing, that is multiplied by 2. Okay, so this is the third step. This is the most important step, that we have to equate the total increase and total decrease by multiplying with suitable integer. Now fourth step is balance other atoms. Other atoms means atoms other than hydrogen and oxygen, and they are already balanced because copper here it is 1, here also it is 1, nitrogen here it is 2, here also it is 2. The next step is balance oxygen and hydrogen. Finally we have to balance oxygen and hydrogen. Now oxygen is balanced by adding water molecules and hydrogen is balanced by adding H plus because it is acidic medium. Now how many oxygen atoms are there? 6. How many are there? 4. So which side is deficient? This side. So I will add 2H2O. Okay, the side where oxygen is less, I will add that much required number of water molecules. So oxygen is now balanced. Now 2 2s are 4. So I will write 4H plus. This is my final balanced equation. Okay, you can check that all the atoms are balanced. Okay, you can check the charge also. Here it is 2 plus charge because others are neutral. Here it is 4 plus and 2 minus. So again 2 plus. So the charges are also balanced. Okay, apart from the atoms. This is the proper balancing of an ionic redox equation. Now we'll take one more example. The next is Cr2O72 minus plus Fe2 plus gives Cr3 plus Fe3 plus, and this equation is also in acidic medium. So what is the first step? We have to write the unbalanced equation. So I am writing the skeletal equation here again. Okay. Now the second step says that find out oxidation number of each element. So we have to find out the oxidation number of each element. Definitely that element whose oxidation state we don't know. Okay, so it is very clear. So here I will calculate for chromium because oxygen I already know it is -2. So it is 2x plus 7 into -2 equal to -2 or x equal to +6. Here iron is +2, here it is +3 and here it is +3. So I have calculated the oxidation number of each element. Now the third step is find out increase and decrease in oxidation number. So we'll find out where it is increasing, where it is decreasing. Okay, so plus Fe2 plus gives Cr3 plus Fe3 plus. So plus 6 plus 2 plus 3 plus 3. So plus 6 to plus 3 it is decreasing, that is reduction, and plus 2 to plus 3 it is increasing, it is oxidation. So we have located where oxidation is taking place and where reduction is taking place. The fourth step is find out total increase and total decrease in oxidation number. So increase is 1 and decrease is now 6 to 3, it is 3. Now whatever increase and decrease is there, that is multiplied by number of atoms. So increase is 1 into 1. Why 1 into 1? Because left hand side also iron is 1 and right hand side also iron is 1. But decrease is 3, which is multiplied by 2. Why 2? Because if you closely see the equation, on left hand side there are 2 chromium atoms, but on right hand side only 1 chromium atom is there. So total increase is 1 and total decrease is 6. Okay, so whenever the number of atoms are more than 1 on either side, we multiply by that number. Okay, it is quite possible that on both the sides two atoms are there. Suppose on left side also 2 atoms are there, on right side also 2 atoms are there, then also you have to multiply. Means when the number of atoms are more than 1, either on one side or on both the sides, you will multiply by that number. So increase is 1 and decrease is 6. Now equate increase and decrease. And how to equate increase and decrease? By multiplying with suitable integers. So I will write the equation. Okay, now increase is 1 and decrease is 6. So how to equate? So increase should be multiplied by 6 so that it becomes equal to decrease. So increase is this part. So 6 here and 6 here. So I will multiply the iron part by 6. Now balance other atoms. So we'll balance other atoms. Now other atoms we need to balance because chromium, okay, 6 I will write here, gives Cr3 plus 6 Fe3 plus. So here Cr2, so I will write 2 here. Okay, so all the atoms other than hydrogen and oxygen are balanced. Now the last part is finally we have to balance oxygen and hydrogen. Now how to balance oxygen and hydrogen? Simply by adding water. So 7 oxygen atoms are there. So what I will do? 7H2O I will add. Okay, because the right hand side does not contain any oxygen. So here 7 oxygen atoms are there. So that side I have put 7H2O. Now how many hydrogen atoms are there? 14. So I will write 14H plus here. So this is the balanced equation in acidic medium. Now we'll take few examples of basic medium. Now one example we'll take of basic medium. Okay. So this is my third equation now. Now what is the first step? Calculate the oxidation number of all the atoms. So the process is same. So here I will find for manganese x plus 4 into minus 2 equal to minus 1. So x equal to plus 7. Here Br is already minus 1. Here Mn is x plus 2 into minus 2 equal to 0. So x equal to plus 4. And here we will calculate for Br x plus 3 into minus 2 equal to minus 1. So x equal to plus 5. Okay, so plus 7 to plus 4 it is decreasing, that is reduction, and minus 1 to plus 5 it is increasing, it is oxidation. Now we'll find out how much increase and how much decrease is there. Now increase is minus 1 to plus 5. So this is the number line. This is minus 1, 0. So you will find that the total increase is 6. Okay. And what is the decrease? 7 to 4, that is 3. Now increase and decrease we have to multiply by number of atoms. So increase is 6 into, now 1, 1, 1. All the atoms are 1, 1 only. So we'll multiply by 1. Now total increase is 6 and total decrease is 3. Now equate increase and decrease. Now we'll equate increase and decrease by multiplying by suitable integers. So increase is 6 and decrease is 3. So what I will do, I will multiply the decrease by 2. So decrease is to be multiplied by 2. Now what is the decrease part? 7 to 4. So twice MnO4 minus plus Br minus gives twice MnO2 plus BrO3 minus. So decrease part will multiply by 2. Okay. Now the fourth step is balance atoms. Now first we have to balance other atoms. So other atoms are I think already balanced, 2Mn, 2Mn, Br, Br. So we'll balance hydrogen and oxygen directly. Okay, since the other atoms are already balanced, so we are proceeding to the next step. Okay, now oxygen we have to balance. 2 4s are 8. Here 2 2s are 4 plus 3 7. So this side is deficient in one oxygen. So I will add one H2O here. Okay. Now I am using a different method for balancing in basic medium. Okay. What we generally do in basic medium, the place where oxygen is deficient, we add water. Now to balance hydrogen, we'll add OH minus. Okay. But I am using a little bit different method, that is much easier method. Okay. So what I will do, first I will balance the equation by acidic medium, although the equation is in basic medium, but I will consider this as acidic medium, and then I will convert acid to base. What I am doing now, hydrogen is 2, so I will add 2H plus. So first I am adding H plus here. Okay, now why I am adding H plus, this will be clear to you after some time. And this is a very easy method for balancing in basic medium. Otherwise what happens, when we add OH minus, again the oxygen and hydrogen increase, so it becomes sometimes difficult for us to balance. So I have added 2H plus here. Now what I will do, we have added 2H plus here, so whatever H plus we have added, that many OH minus will add on both the sides. So I will add 2 OH minus here and 2 OH minus here. Okay, so whatever H plus we have added, that much OH minus will add on both the sides. Now 2H plus and 2 OH minus, now H plus and OH minus change to water, so they will change to 2H2O. Okay, so this part is converted into water. So you can see that now H plus is removed. Okay, so this is the equation. Now here H2O is there, here 2H2O is there, so I will subtract. So my final balanced equation is this. This is my final balanced equation. So you can see that now H plus are removed and we are left only with OH minus. Okay. So this is how we can balance the equation in basic medium. Okay. We'll take one more example. Now again we'll take the example, and this is also in basic medium. So the first step is calculate oxidation number of all the elements. So here we'll calculate for chromium. So x plus 3 into minus 1 equal to 0. So x equal to plus 3.
Now plus 3 to plus 6 increase is 3, that is increase, that is oxidation, and plus 5 to minus 1 it is decrease, so it is reduction. So how much increase is there, that will calculate. 3 to 6, that is 3, and how much decrease is there, the decrease is 5 to minus 1, that is 6. Now increase and decrease we have to multiply by number of atoms. So 3 into 1 and 6 into 1. So increase is 3 and decrease is 6, because on left hand and right hand side the number of atoms are 1, 1, 1 and 1. Now equate. Increase we have to multiply by 2 so that it gets become equal to decrease. So what is the increase part now? Now 3 to 6 is the increase part. So 2 CrOH whole 3 plus IO3 minus gives 2 CrO4 2 minus plus I minus. So increase part we have multiplied by 2. Now we'll balance the atoms. Now first of all we'll balance the other atoms. So other atoms are already balanced, so we'll balance oxygen. Now 2 3s are 6 plus 3 9 oxygen are there, and here it is 8. So I will add one H2O here. Now how many hydrogen atoms are there? 2 3s are 6 and here 2 hydrogen atoms. So I will add 4H plus, because this side is deficient in hydrogen. So it is not necessary that on one side H2O will come, so on opposite side H plus will come. No. We have to balance the number on both the sides. So it is quite possible that sometimes water and H plus or water and OH minus are added on the both sides. So now I will write, and how many H plus I have added? 4H plus. So I will add the same number of OH minus on both the sides. So I am writing the final equation. So this is 4H plus and 4OH minus. Now 4H plus and 4OH minus are 4H2O. Now 4H2O plus 1H2O, that is 5H2O. Okay, so this is my final balanced equation. You can see all the atoms are balanced now. The charges are also balanced. Okay, so this is how we can balance the equation in basic medium. So first we'll balance according to the acidic medium, and whatever H plus we have added, the same number of OH minus will add on both the sides. So this is the first method of balancing the equation, redox equation by oxidation number method.